yesterday. Friday, before we stopped our notes for 3-2, we talked about exponential and logarithmic graphs and how if I knew the exponential rules, I automatically knew the logarithmic because exponential and logarithmic equations are what of each other? Not equivalent. Inverses. And inverses physically interchange the range and domain. So I know how to do that. And this is just an example of this so we can retrack what we were doing. Here I have 2 to the x. And if I wrote this in logarithmic form, would I not have log base 2? Yes?
Yeah.
Okay, so I should know that this is the exponential y. How should I know that that one's the exponential without it telling me?
Because it doesn't have log in it?
No, I'm just, if I had the graph. If I just had the graph, how would I know that this one is an exponential? It goes up, right? And where does it go through? 0, 1, right? And why does every exponential before you move it left, right, up, down, go through 0, 1? And anything to the 0 is what? 1.
Yeah.
Okay? So if your x is 0, you go 1. So then I interchange range and domain, and I go through now 1, 0, and I look like this. They are reflected across the y equals x line, that identity line. Every point is interchanged the range and domain. So we are going to move these left, right, up, down, reflect them over the x-axis, reflect them over the y-axis. We're going to do that to these. Okay? And they will be exactly what they were before. So we have plus or minus, plus or minus a log base b, we'll put a b, of x minus h plus k. What does this do? Okay, this would only be the x-axis, correct? This one's the x-axis. Okay, a, the slope, the rate of change. Okay, we can't say slope because it's like the average rate of change. We can say that. So if it is less than 1, it's a half, it's going to be wider. And what it comes down to is the x-axis. So if it's between 0 and 1, it comes wider like that. If it is greater than 1, it's going to come closer to the x-axis. Think about with your exponential, the greater the degree, the closer to the y-axis it was. It's the same thing here. Okay? B is my base. That's just my starting point. There should be a plus and minus here. What does that reflect over? The y-axis. Okay? And then the H? Horizontal, so left and right. K is up and down. The book tends to write the K in the front. Does it matter where the K is at? No. Does not matter at all. Okay, so it says describe the change. I would highly suggest you use parentheses, even though the book doesn't put it, because this is exactly how the book would write it. And they say if there's no parenthesis, you assume it's not in there. But I personally would write log base 3 of x in parentheses minus 1, because that clearly tells me that that negative 1 is a what? It's an H or a K? It's a K, because it's not grouped with the x, correct? Okay, so the only thing so we have the point of 1, 0, yes? Where is 1, 0 going to go?
It's gonna go towards the
Wider.
It's gonna go towards the y-axis.
It's going to go towards the y-axis a little bit more than 2, but that's not what I'm talking about.
Down.
What about the negative 1?
Down.
It's going to go down 1, so 1, 0 is going to be what point?
0.
1, negative
1,
Negative 1. No, yeah, 1.
1, negative 1. How did you get that?
1. Because the case would have went down.
You just subtracted 1 from the y, right? That's it. So my graph, instead of going right here, it's going to go through right here. Now it would have a different x-intercept now, wouldn't it?
Yeah.
Okay.
Does it really matter where you're
At some point we will calculate the x-intercept. But not today.
Okay.
Okay, what's going to happen to this one?
H.
It's an H, yes?
Yeah.
What's this do?
It's gonna reflect it.
Reflect on the X.
Stop. Whoa.
Okay, so it's going to reflect over the x-axis.
And that's because
And-
there's that
And
negative
it's
in front of the
gonna
log.
go 3 up. Wait, over 3. 1,
So that's gonna
3,
be,
1.
Which way 3?
it's gonna,
Go zooming up. It's gonna go
To the right.
to the right.
It's going left 3 way. Why, Alex?
Because it reflected first.
Well, no, because it's a what?
Negative.
It was a negative for that to be a positive, correct?
yeah,
Okay. So left 3 would do what? It'd be minus 3.
it'd be negative 2.
It'd be negative 2, 0.
Wow,
So-
it's
Bring
a
this back.
wait, right now.
Oh, yeah, for sure.
Now over here, I didn't talk about the domain, did I?
No.
Because it didn't move left or right. The domain is still x such x is greater than 0, yes?
Yeah.
Okay, but now, since I'm moving back, what is my range going to be now?
X such that X is less than 0.
Oh wait, I didn't reflect,
Yeah.
which reminded me, so I need to reflect. Ooh, that's a big eraser. Yeah, just erase and start. Okay, I didn't reflect, sorry guys.
We don't make mistakes there.
Everybody makes mistakes.
Okay, so when I initially, it would go like this, yes?
Yeah,
But it's reflected over the x-axis, so it's gonna go,
it's gonna go down.
it's gonna go, like this. Okay, but my domain is not gonna be less than, it's gonna be what?
Greater than.
Greater than,
Negative 2. 0. 1.
No,
it was 0, yes? Over here, it is 0,
yeah,
and everything's going back how much?
Negative 3.
It's going negative 3, so I take 0 minus 3 is,
Negative 3.
so my new asymptote that I would show on here, because it's just an asymptote now, right?
so it's gonna be
Negative 3. Because everything just went back that negative 3. Yes.
because this is like the log 3, like just the log, so what, like X such that X is greater than negative 3, would that be a range, but it's just opposite?
No. In here we've now switched it so x is, like if we put this in exponential notation, then y would be in my,
Oh,
okay, but in log, it's just x.
okay.
I mean, actually, whatever variable's in your log function, and in the log function is x, so that's what it is. Okay, now, what's happening here?
H. Yes.
What's different about like this one and that one?
It has 3
That one,
minus X.
3 minus.
It has 3 minus x, so could I rewrite
We
it?
need a reverse.
I think so.
I think you can rewrite it. X plus 3.
No, yeah,
No,
negative x.
Negative X, yeah, plus 3.
Tori, is that what you were gonna ask? You had your hand up.
Oh, I forgot.
Okay, so now I need to think about this. This reflects it over what?
The Y axis?
The y-axis. So it looked like this. Now it's gonna look like what?
it's gonna,
It's gonna go that way, right?
yeah, so it's gonna be that.
It's gonna go negative instead of positive?
Yeah.
Or on the, yeah, it's gonna go towards negative infinity, not positive infinity.
Yeah.
it's still, technically what you should do with this is this. Okay. So this tells me I'm moving what direction?
You're moving right.
Right. So 1, 0 is going to be what?
4, 0.
4, 0. What did I do from here to here, first of all?
Distributed out the
Yeah,
negative.
Factored out.
Factor.
But yes, you're right. Factored out the negative. So I'm going to go right 3, and then I'm going to go this way, yes?
Yeah.
Okay. And I don't know why I made it so small. Let's make a smaller eraser this time, though. Okay. Now, everything has to go right 3. So what also has to go right 3?
The domain.
The domain, right? So it's going to go from 0 to what?
4.
4?
0 to 3.
1, 2, 3.
Yeah.
Okay?
Why does it say 4, 0?
Because you add 3 to 1.
Yeah, but our mark.
Then why are we
Right.
grabbing a 3?
Oh, okay. So it goes to 4, yes?
Yeah.
But then it's reflected, so it goes back to where?
3. Why is it
So
reflected 1?
It's going like this, yes?
Yeah.
But then this does what?
It reflects all the way.
Reflects, well, yes, but our new axis is
That.
There.
3, yes?
Mm-hmm.
Yeah. Where'd you get 3?
She got 3.
Everything moved right 3, yes?
Yeah.
Okay, so that means our asymptote that was the y-axis moves right 3, yes?
Okay, so now that's
Yes.
you reflecting.
And so now I'm at 4 because we said 4, 0.
Yeah.
But now I have to reflect it over here. So I'm 1 to the right. Now I'm going to be 1 to the
Left.
left.
Okay.
So you're going at 2?
Yes, that's 2. It's just getting worse.
Oh, look at the how.
I can't get through 2 evidently.
Should we be like writing the isotope things?
Yes, you should be showing your asymptotes. My pen must be off down here. Anyway. Okay, so when it's reflected over the y-axis, does it twist our brain a little bit? Yeah. So you got to kind of think about, okay, it originally came here, then I have to reflect over that the new y-axis because we moved it. Okay. We won't do a whole lot of these. They're icky.
Whole lot of what?
The reflection over the y. Okay, so we had a natural exponential function that was base e, correct? So guess what we have? A natural what? Logarithmic function that's also base e. Anybody know what e is? Approximately?
0.2 something, 248.
7 point like.
2.7182818281828.
Why do you have that memorized?
Because she's an
It's 1828. You should know it's 2.7, approximately 2.7.
I know,
I
It's
knew
just
that.
1828.
Why do you need all the other?
Okay, because it's 1828 repeated.
I said
Okay, so a logarithmic function with the base of e is called the natural logarithmic function, and it is written ln. It is on your calculator right below the log button, the button below your log button. And it is, this is why we don't do it. We have log base e of x. That's just log e, log e. So, we write ln x. What is the base of ln? What's the base?
N.
No,
E.
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 E. Every time you see natural log ln, the base is e. It will never be anything different. Like log, I can have any base, correct? But they have a special abbreviation for log base E, and it is natural log. Are these rules exactly what I gave you for log?
Yep. Just switch it with the E.
Log base A of 1 was 0, yes?
Yeah.
So it doesn't matter what my base is, it's still going to be 0. Well, this is natural log. I said when the bases are the same, right? What's the base of natural log? E, right? So it's 1. And this is, remember 2 and 3 are the same rule? So if you're going to remember one of them, remember rule 3?
Yeah.
Just the exponent. And the base here is E, and the base here is E, so the answer is X. And then my 1-to-1, natural log of X equals natural log of Y, if and only if X equals Y. Same exact rules. But now my base is what? E. So don't ever tell me natural log base 7. What's wrong with that?
Because it's not.
Doesn't it equal
It's not. What is the base of natural log always?
2.7?
E.
So E space, E base 7?
No, it wouldn't be a thing.
No, it's E base 7.
Mask on.
Oh. Hey CJ, why don't you cheer up a little bit? Don't be so
Are we good yet? We good?
Yeah.
Shelby, you good?
No, not good. Sorry.
No, that's okay.
Turn that frown upside down, dude.
No, don't go yet. Can I take a picture of it?
No, write. It's in the book if you can't get it. Hurry up and write. No, stop. Write.
Well, then you just pressure me like that. I just won't
Write
write it.
it.
Everyone's waiting on me.
It's okay.
Well, you should be almost done, so finish.
Honey, I'm still writing. Don't feel bad.
I just asked if you were done. That was it.
Yeah, I'm done. I about let a word slip right there. Through that.
Sadie, are you done? Okay.
We'll finish. I'm just kidding.
Okay.
Oh my god.
Natural log of 1 over E. So I need to get these so they're powers of E, yes? So 1 over E can be written as E to the what? Negative 1. So I have natural log of E to the negative 1 equals what?
Equals,
negative 1.
Negative 1 by what rule?
yeah.
0 equals negative.
Rule.
Rule 3.
Rule
1
3.
to 1.
That's what I heard it earlier. I just
Okay.
couldn't remember.
Rule
That's
3
the
is,
one-to-one
rule 3 isn't 1 to 1. Rule 3 just says if the bases are equal, it's the exponent. The answer is the exponent. That's all Rule 3 says.
Okay.
I got a question.
What?
If it's natural log, then why does it go ln and not L?
I don't know.
Makes no sense. It's like log natural.
It's the log with the natural base. Okay, so what's the base of natural log right here?
Um,
No,
10.
what?
10. No.
No,
E.
not E.
I said that.
One person did. Other people did not. Okay, the base is E here. So I have E to the natural log of 5. So the answer is 5. By rule what?
5.
3. 4.
I guess 3.
No, that's 3. You're
Gosh,
3.
I'm dyslexic.
You're right.
That was right. Yeah.
You're right. Because the bases are equal, yes? Just because it's written in exponential form, it still works. If you want to, you have e to the natural log of 5 equals x. We'll just make it equal x, okay? So this is in logarithmic form. Let's put it in exponential. Or this is exponential. Let's put it into log. Got it? Okay. So it's going to be base what?
E.
E. So we're going to use natural log.
Yep.
So natural log of x equals natural log of 5. So x equals what?
5.
5. That's why that works.
Because those natural logs cancel each other out.
They don't cancel each other out. It allows me to use rule 4,
Oh, looks like
the one-to-one property.
So,
looks
They
like-
don't cancel each other out. Okay, so now I have the natural log of 1 over 3.
1/3.
Well, It is, that's written 1/3 the natural log of 1, yes?
Yeah.
I mean, that's what it is, yes?
Yes.
Yeah.
So what is the natural log of 1?
1.
Zero.
Zero. Zero
'Cause
by
it's that
what
1
rule?
equals 0 thingy.
By what rule?
1.
4.
By rule 1.
Oh yeah.
One.
How do you know this? I honestly
Second.
don't.
It's right here. She literally just had them up for like 5 minutes.
Yeah, I know. I have this, but I don't get how you're reading that. Like, I really don't.
Okay, rule 1 was natural log of 1 is 0.
Right, Mike?
That's the rule. So, natural log of 1 is 0, so the answer is what? 0.
Syrup.
Okay. What is the base of natural log?
E.
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 So the bases are the same, right?
Yes.
So what's the exponent here?
1.
1. So what's the answer for just the natural log of E?
1.
1. By what rule?
3.
2.
You can use 2 or 3, whichever one.
Just use 3.
If 3 is a general rule, 2 is a specific rule. We talked about that on Friday, right?
Yeah.
So if you want to use less than the amount you need, you just need 3. So the answer is just what? 2.
Okay, but never mind.
So a lot of your assignment on Friday was using those rules, right? So you should have those rules down really easily because do they change between natural log and log?
Not really, no.
Okay, I did Friday's lesson and I still don't know this. So.
Okay, so hopefully by the end of today you'll know them because you need
Maybe
them.
I'll get really smart by the end of the day.
Let's hope.
Because when we solve the equations, because tomorrow we're going to solve them. Okay, because the function e to the x, look at this graph and I don't want you to write it down. Okay, e is a number, yes?
Yeah.
It's not anything special.
Yes.
We saw it before. The exponential function just looks exactly like any other exponential function, correct?
Yeah.
So is this logarithmic function going to look exactly like every other logarithmic function?
Yep.
Yes. Okay, so e is just a natural base. E is a number that is approximately 2.7. So it's just a number. Did it change anything? Did I still go through 1, 0?
Yes.
Yes. The only thing that's going to change is my decimal approximations as I go. It's a little bit bigger than 2. It's actually almost 3, right? But it's not 3. So when I graph it, if 2 was here, 3 would be here. Because it would be closer to 3 than 2, correct?
Yes.
Okay? That it's just, it's no different. None of my rules are different. I'm not going to write anything differently because my domain is still what?
Domain is still
X is greater than 0.
X is greater than 0. My range is still
1.
all real numbers. My x-intercept is 1, 0, and that's what I'm going to move around. Nothing else. Is my h still going to do the same thing?
Yep.
Is my k still going to do the same thing?
Yep.
Yep. Everything is going to be exactly the same. It's just the base is e. That's it. So,
I'm gonna edit her.
the negative natural log of x minus 2. Am I going to do these any different than 4 slides ago when I did this?
No.
No. It's going to move right to and reflect over what? The x-axis.
And you got
So 1, 0 is going to go to
gonna go to 3, 0.
3, 0.
You're so good, CJ.
I know.
Okay.
I should be.
My vertical asymptote was x equals 0. Now it's going to be x equals what?
X
2.
equals
Oops.
3.
2.
Oh,
Yes.
Okay, that's an equal sign. Okay,
I don't know how to do that. How'd you get that?
because
because
she.
everything is going right to. Everything is going right to, and a vertical asymptote is an x value, so it will move. And it's not going to increase, it's going to what?
It's gonna
Decrease.
Decrease.
You said it's not gonna increase, so it's gotta
I talked to him.
If it doesn't increase, it decreases.
Why didn't you reflect it like what we did last time?
Because when we do
because-
the reflection over the x-axis, it's just gonna go increasing or decreasing. The y-axis is the different, like we didn't reflect it over this tube. Now, if I had a negative in here also,
Oh, okay,
then it
never
would
mind.
come, then it would go like this,
Alright,
okay? So this right here
Mhm.
would be that,
okay.
okay? Actually, this, guys, right here, that is that graph. Well,
Okay.
kind of, okay? But
Wait a minute.
it's gonna go there. If I did this in that graph, it would be that.
Yeah.
Okay, so when I do, the only reason that the Y reflection happens is because of the fact in here it does change. Like a parabola, a Y reflection doesn't change. So we tend to use our H and K to show that rather than trying to wrap our brain around, let's move it here and then reflect it over here, because sometimes reflections mess with us a little bit when they're vertical reflections. Horizontal reflections just, it's not tied with the X. So this right here, everyone, is this problem right here.
But you reflected it
Yep.
over your y-axis.
Okay, so what's happening here?
A lot of things. are
They
happening.
put the K in the front.
Oh,
They put the K in the front. That's all they did.
You're so smart.
So 1, 0 goes to what?
Goes wait.
1, 2.
One negative 2.
Yeah,
Yeah.
one positive
No.
2.
Yeah. One positive.
Why is the 2 there now?
Because they put it there. It's a K.
No. Why is the 2 going? Why is it going from 1, 0 to 1, 2? When
Because
it was
it's a
just
K.
going-
Because this is a K and this is an H.
How do you know?
Because this is grouped with the X and this is not. Just like every other equation we have.
You got it, Maddie.
Okay, so we're gonna go 1, 1, 2.
They do your parentheses.
Yeah, they didn't. They should have. Honestly, guys, those parentheses will help you know it's not an H. Yes.
Okay, I just have a question on why that, like, okay, why.
Can we finish this one first?
Yeah.
Thanks. Okay, so did I move it left or right?
You moved it.
No. Did I move it left or right? No. So my vertical asymptote isn't going to change. My domain is not going to change. The only thing that's going to change is my what?
Where the point is.
Where the point is. My x-intercept is going to change, and right now we're not worried about what that x-intercept is. We will worry about that in a couple days. Okay, so that one's done. Tori, yes, back
Okay.
here.
I have a question why when you go from 1, 0 to 3, 0, like, why wouldn't you subtract 2? Because on that one you just add 2, so why don't you do 1 minus 2?
Because the formula is h minus k, or x minus h, remember? Plus k. Plus k. And so this is whatever sign it is, and this one's the opposite every time.
Oh, because it's in front.
It's in the parentheses. It's an H,
I
and
got
H
a
is always
question.
on.
Okay, I get them.
Yes.
But
What?
a house to a K.
Because it's not grouped with the X.
You can go anywhere.
Oh.
It's not grouped with the X. It's not in the parentheses. It's
That's how you know what.
See, like the bottom one, that one's an H.
like
because
this
it's
is an
grouped with the
H.
X.
It's grouped with the X. Anything grouped with the X is an H.
Okay.
So I could have written this natural log of X plus 2. Yes. Is this exactly the same as that?
Yeah.
Yes. It doesn't matter.
Parentheses around the L and the X to separate them from
Well, the X, not the ln. The ln is the function.
the two.
The natural log is the function, so you don't put parentheses around that. But that's why the parentheses are important. Okay? It will help you see what is an H and what is a K. And that's it. That's all I got for today.
Yeah.
So
what's the
all
answer
you're
for the
doing,
bottom one? What's the answer for the
right here,
I thought you said it would be flipped because it's not.
I did. I added a negative. I added a negative in front of it, so I showed you how this.
Wait, would your point be negative 1, 0?
No, you okay. The first equation moved and went this way. Yes? This equation down here, the only thing I'm changing is changing the negative here, so I'm doing it this.
Wouldn't it
That's
be-
why I added this negative.
Wouldn't it? Oh, you added it.
I added that negative so you could see how that extra reflection would give you the mirror image.
So it'd
Find a
be
piece of
1, 0 to negative 1, 0?
That's if you don't have.
Yeah, I
a
can get
negative.
that.
Yeah, because if you would have negative x plus 2, and then you'd factor out a negative. Yes?
Yes.
You would factor out a negative, and so you would move everything right. You would move everything right too, and so you'd end up here, but this would reflect it across the new y-axis, so you would end up here. When you have this, the key is to rearrange it and factor out.
So we don't have a thing that goes like 1, 0, arrow to.
Yeah. It would be 1, 0, and it would go to 3, 0, but then when I reflect it, it's going to go back to what?
Okay.
1, 0.
Now we just start our assignment.
Okay, your goal is to know those